Good morning, all. Myself, Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So, today class we are going to discuss about Chebyshev Low Pass Filter. So, first, Chebyshev Low Pass Filter is another method of designing an IR filters. So, we have two specifications, that is a Chebyshev filter 1 and filter 2 types. So, first we see these steps to design an analog filter. So, first is, so from the given specification, find the order of the filter n. So, we need to find the order of the filter n. This is the first step. Second step, round off it to next higher integer. So, round off it to next higher integer. So, this is the second step. Third step, using the following formulas, find the minor and major axis A and B. So, the formula is A equal to omega P into mu power 1 by n minus mu power minus 1 by n divided by 2. And then B equal to omega P into mu power 1 by n plus mu power minus 1 by n divided by 2. So, this A and B will be a minor and major axis of an ellipse. So, normally if you take a Butterworth filter, that poles will be available in a circle. If you take a Chebyshev filter, that poles will be available in the ellipse. So, that's why for an ellipse we need to use only a minor and major axis to represent. So, that's why we are going to find this A and B value here. So, we know that how we need to find these components. So, mu equal to epsilon power minus 1 plus root of epsilon power minus 2 plus 1. This is the formula used to find a mu value. Epsilon equal to 10 power 0.1 alpha p minus 1. So, this is common to Butterworth filter also. So, we know omega p is passband frequency. Alpha is the attenuation. That is the maximum allowable attenuation in the passband frequencies. So, for a normalized Chebyshev filter, we use this omega p will be equal to 1 radians per second. So, this is called normalized filter. So, both Butterworth and Chebyshev, whenever you use the normalization, we use the cutoff frequency as 1 radians per second. After that, we can transfer the required filter for specification. So, next step, we need to calculate the Chebyshev filter that lies on ellipse by using the formula. So, we need to find the poles Sk. So, S1, S2, S3 up to n value. So, Sk equal to A cos pi k plus JB sin pi k. So, here k is equal to 1, 2 up to n. For all the order of filter n is 4 means we need to take from 1 to 1, 2, 3, 4. So, for substituting we need to have a pi k. So, pi k is given by pi by 2 plus 2k minus 1 divided by 2n into pi. So, where k is equal to 1 to n. So, by using this pi k, we can find the Sk. So, Sk is the pole. S1 is pole 1, S2 is pole 2. Like that, we need to find, if it is an order of filter is 4 means, we can find S1, S2, S3, S4. So, next step, so find the denominator polynomial of the transfer function using the above poles. So, once if we find that these poles S1, S2, S3, we can find the denominator function. So, normally if we have an odd number or even number of n, so we each poles will be available in two manners. That is, a complex conjugate of the poles will be available in opposite. So, by combining these two poles, we can get a one equation. So, similarly, we can combine all the thing and we can write the expressions in the denominator function. So, by using this denominator, we need to find a numerator function. That is step 6. So, the numerator transfer function depends on the value of n. So, n may be odd case or n may be even case. It decides whether the oscillation curve should start 1.0 or it starts with epsilon. So, for n equal to odd, substitute s equal to 0 in the denominator polynomials and find the value. So, this value is equal to numerator transfer function. So, reason is n is odd, magnitude curve h of e power j omega starts at the value of 1.0. For n equal to even, substitute s equal to 0 in the denominator polynomials, also divide the result by root of 1 plus epsilon square. So, this is the reason is the oscillation curve starts at that value of 1 divided by root of 1 plus epsilon square. That's why we are dividing the value by this 1 plus root of epsilon square. Look at, we can see one problem. So, the given specification alpha p is 3 dB, alpha is 16 dB, fp is 1 kHz and fs is 2 kHz. So, determine the Chebyshev approximation, find h of s. So, from the given specification alpha p is, so they given is a frequency in terms of hertz, that's why I am going to convert in a radians per second. So, just here is 1 kHz, this is 1000 hertz. So we can convert omega p equal to 2 pi into fp. So 2 pi into 1000 hertz, that is equal to 2000 pi radians per second. This is omega p. Omega is also equal to 2 pi into, they given us a 2 kilohertz, this is the 2000 hertz. So 2 pi into 2000, that will be equal to 4000 pi radians per second. We converted omega p in omega s in radians per second. Now we have alpha p and alpha s, this is 3 dB and 16 dB. Now we can find this n. So n greater than equal to cos hypotenuse inverse of root of 10 power 0.1 alpha s minus 1 divided by 10 power 0.1 alpha p minus 1 whole divided by cos h inverse of omega s by omega p. Just substitute this value. So we take this cos h inverse. So 10 power alpha s is 16 dB. So 16 into 0.1, this is 1.6. So 10 power 1.6 minus 1 divided by, so here this 0.1 into alpha is p is 3. So 3 into 0.1 is 0.3. So 10 power 0.3 minus 1 whole divided by cos h inverse of omega s by omega p. So omega s is 4000 and omega p is 2000. So 4000 pi divided by 2000 pi. So simplify, we get n greater than equal to 1.9. Now we need to round up it to the next higher integer. So n rounded to next higher integer. So n equal to 2. So n is even, so the oscillation curve starts from 1 divided by root of 1 plus epsilon square. If it is odd, it starts from 1. If it is an even, it starts from 1 divided by root of 1 plus epsilon square. Now we need to find a major and minor axis. So to find a minor and major axis, we need to have a mu. So we need to have a mu, find first epsilon. So epsilon equal to 10 power 0.1 alpha p minus 1 whole divided by 0.5. That is the square root of 10 power 0.1 alpha p minus 1. So if you substitute it, we get epsilon equal to 1. By using epsilon, we can find a mu value. So mu equal to epsilon power inverse plus root of 1 plus epsilon power minus 2. So if you substitute here, we get a mu equal to 2.414. So by using these two value, I can find a major and minor axis. So a equal to, we have the formula, just substitute this value, we can find an a value here. Similarly b, we have the formula, just substitute these values, we can find a b value. So a equal to 910 pi and b equal to 2197 pi. By using these two value, we can find the poles. Next, sk, that will be equal to a cos pi k plus jb sin pi k. So we first find the pi k. So we have the formula for pi k. So n is 2. So we need to substitute only 1 and 2 values. So we need to find pi 1 and pi 2. So this is the pi by 2 plus pi by 4. By using this simplification, that will be equal to 135. Similarly, pi 2, pi by 2 plus 3 pi by 4, that will be equal to 225. So this is a pi 1 and this is pi 2. So I get a S1 and S2. So this is S1 and this is S2. We already find the A and B value. Now we have find this pi 1 and pi 2. We substituting this. So S1 becomes A cos pi 1 plus JB sin pi 1. So we already find this A and pi 1. So substitute this. So we get minus 643.46 pi plus J 1545 pi. This is S1 and S2 is minus 643.46 minus j 1554 pi. Look at this S1, S2, both have similar things. Only change is the complex conjugate manner. Look at this. This is only changing the plus or minus. So these two we need to take only one poles. So denominator function is, we need to take s plus real part square plus imaginary part square. So this is the real part and this is the imaginary part. So s plus real part is 643.46. So s plus real part whole square plus imaginary part is 1554 pi square. So this is the denominator function. Now we need to find a numerator function. Simply substitute s in equal to 0 in the denominator function. Also divide the result into 1 divided by 1 plus epsilon square. Look at this. So I am substituting s is equal to 0. I get only this expression divided by 1 plus epsilon square. So this is the numerator function. Now find a h of s by substituting a numerator and denominator function. So this is the numerator value and this is the denominator value. By substituting this, I get a h of s. Thank you.